students, welcome to Sunil's tutorial. I'm Sunil Birwani and today we'll be doing this chapter called as network analysis. Let's see how to do crashing. I'll just explain what is crashing to you first. Let me write the sum down, guys. Nodes or activity. Activity is also called as nodes. 1, 2, 1, 4, 2, 4, 2, 3, 2, 5, 3, 4, 4, 6, 5, 6. Normal. Time and cost. 8, 10, 5, 6. 8, 0, 12, 5. 1500. Copy the sum down, guys. 1500, 2000, 800, 1100, 900, 0, 300, 500. Crash. Time, cost. 6, 7, 4, 4, 5, 0, 8, 4. 2000, 3000, 1400, 1500, 1500, 0, 400, 800. Right? Now first of all, what do I understand by crashing? When an activity can be done, when an entire process is done in n number of days, by asking you or by asking the labor to work overtime, I can get it done in less time. What is crashing? Crashing is getting it done in less amount of time, in less period, right? For which obviously I'll have to incur some charges. Now I have to make sure that my time duration is reduced in such a way that my charges do not increase. I'll show you this with the help of the sum. Okay. Now, first of all, let's draw the network diagram for this, guys. From 1, guys, first thing that you have to do is draw the network diagram. From 1, you have 2, and from 1, you have 4. Right? From 1 you have 2 and from 1 you have 4. From 2 you have 3 and from 2 you have 4. So from 2 you have 3 and from 2 you have 4. From 2 you have 4 and 2 you have 3. From 2 you also have 5. From 3 you have 4. From 4 you have 6. And from 5 you have 6. Right? Let's write the normal time down. From 1 to 2, we'll call this as activity A. This is 8 days. From 1 to 4, activity B is 10 days. From 2 to 4, activity C, which is 5 days. From 2 to 3, activity D, which is 6 days. Then from 2 to 5, activity E, which is 8 days. From 3 to 4, activity F, which is 0 days. That's my dummy, right? I could show it with dotted lines. Okay, and then I have from 4 to 6, FG. G is, say, 4 to 6 is 12 days, and from 5 to 6, H is 5 days. So my network diagram is ready. Okay. Next, the next thing I have to do is I have to find out all the possible paths. I have to move from 1 to 6. Let us see what are the various paths I have. AEH, I can say that A D F G, then I can say that A C G, then I have this path, this, then I have B G, right? So these are my multiple paths that I can use. I have 4 different paths. Time. If I use AEH, that is 8 plus 8 plus 5, 21 days. Then if I use AD, 8 plus 6 plus 0 plus 12, 26. If I use ACG, A, 8 plus 5 plus 12, 25. If I use BG, 10 plus 12, that is 22. Right? So the maximum duration is in the path ADFG. Right? So that is going to be my critical path, and the time that I will get will be my project completion time. Will be the maximum time is my project completion time, which is going to be 26 days. Right? So I can say that critical path is ADFG. Now people, please remember one thing here. Why have you selected ADFG as critical path? Because it is the path that has maximum duration. Please bear that in mind. So the critical path has to be the path that has maximum duration. Okay, and my normal project completion time, normal project completion time is 26 days. Okay, now next I need to find out my direct cost. How do I find out direct cost? Very simple, guys. Whatever is my normal cost, they have given you normal cost in the sum. If I add all the normal cost, what I get is called as direct cost. If I add all the normal cost, what I get is called as direct cost. So that is going to be 1500 plus 2000 plus 800 plus 1100 plus 900 plus 0 plus 300 plus 500. So 7,100. Right? Now I presume I haven't given you some data in the sum. Okay. Just write this data down in the sum. There's one part of the question. Indirect cost is 200 rupees per day. That is given to me in the sum. Okay. So the indirect cost is given to me. So I found out critical path, I found out normal project completion time, direct cost. Now indirect cost. Indirect cost they've given you is 200 rupees per day, and my project gets over in 26 days. So in that case this should be 5200. Therefore my total cost is direct cost plus indirect cost. Direct cost is 7,100, indirect cost is 5,200, 12,300. So my total project cost is 12,300. Can I finish the project in less than 26 days and pay less money? That is what is crashing. Let's see how do we do crashing. Right? For crashing, the first thing I need to do is I need to make a rank table. Right? So let's write the activities down. D. I'll make the table here. You have activities A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H. These are my activities, right? Now, once I have the activities, the next thing that I need to do is I need to find out the maximum crashable limit, right? How do I find out maximum crashable limit? Maximum crashable limit is given by the formula normal time minus crash time. Maximum crashable limit is given by the formula normal time minus crash time. So for activity A, normal time and crash time is given to you 8 minus 6, 2 days. For activity B, 10 minus 7, 3 days. For activity C, 5 minus 4, 1 day. For activity D, 6 minus 4, 2 days. For activity E, 8 minus 5, 3 days. For activity F, 0 minus 0, that's 0. Then for activity G, it is 12 minus 8, 4 days. And for activity H, it is 5 minus 4, 1 day. Right? So we understand?
So crash time will always be less than the normal time.
Yes, crash time will always be less than the normal time. Right? Next, the next thing I need to find out is cost slope. Right? I'll write the formula for cost slope here. Cost slope is given by the formula crash cost minus normal cost upon normal time minus crash time. Right? So my cost slope for activity A is 2000 minus 1500, 500 divided by 2, 250. Then this is going to be 3000 minus 2000, 1000 divided by 3, 333.33. Okay, 34.
3, yeah.
Okay, 33. Fine. Then you have 1400 minus 800, 600 divided by 1, 600. Then you have 1500 minus 1100, 400 divided by 2, 200. Then you have 1500 or 1500 minus 900, 600 divided by 3, 200. This is 0 because everything is 0 there. Then you have 400 minus 300, 100 divided by 4, 25. And finally you have 800 300. Right? So that's how you get your cost slope. Once you get the cost slope, you need to rank them. Right? Now when you're ranking them, you have to rank them in ascending order. 0 is not to be ranked because that's a dummy activity. Right? You need to rank them in ascending order. Now the smallest number here is 25. So 25 gets first rank. Then you have the next closest number is 200. So both of these get second rank. Then you have 250, third rank, fourth rank, fifth and sixth rank. Right? So this is my cost slope table. Right? First thing that you need to do is make a cost slope table. Fine, do we get this in here?
Can you write that in the box?
What? The cost slope table? This is cost slope table. Right? Once I have the cost slope table, guys, now I will start with crashing. I explained to you what is crashing. Crashing is wherein you reduce the project completion time. You not only reduce the project completion time, but you also reduce the total cost of the project. You reduce the project completion time and total cost. Let's see if we can do that. Right? You need to make crash table. Right, first crashing before crashing. Then you have to write all the paths that you had. The paths you had was AEH. Then you had ADFG. Then you had ACG. Then you had BG. Then you write direct cost, indirect cost, total cost. Right? That's how you make the crash table. So you have the first column, that's your particulars, the paths, direct cost, indirect cost, and total cost. Let's write the duration, guys. Now, the duration is for AEH, it was 21 days. Then it was 26, this is my critical path, 25 and 22. Direct cost we had found out was 7100. Indirect cost I have found out is how much? 5200, and my total cost is 12300. Now let's understand the rules of crashing. You always crash only those activities that form your critical path. Right? First rule, you will crash only those activities which are a part of your critical path. Second, when you're crashing, you have to look at your cost slope table and you have to crash in the order of ranking. Right? The highest, that is your rank 1, will be crash first and then second and so on. Now let's see this. My critical path is ADFG. Critical path is ADFG. A has rank 3, D has rank 2, F is not considered, G has rank first. So when you start with crashing, you will crash G first. Okay, do we get this in clear? So when you start with crashing, you have to crash that activity which has first rank in the order of the rank, right? So first crashing. When you are crashing, now if you look at G, guys, your crash time of G is 4 days, right? You will not crash all the 4 days simultaneously. You have to crash 1 day at a time. Crashing is done by doing it you have to crash 1 day at a time, right? So first crashing G by 1 day. If I'm crashing G by 1 day, wherever or in all those paths where I have G, the number of days will get reduced by 1. So this will still remain 21 days, this will become 25 days, this will become 24 days, this will become 21 days. I'm crashing G by 1 day. So all those paths that have G will be reduced by 1 day. Fine, do we get this?
By 1 day because the rank.
Yeah. No. When you're crashing, you will always reduce by 1 day. Okay. Now, my crash cost of G is 25 rupees. So my direct cost will now become 7100 was my cost, plus to crash G by 1 day, the overtime that I have to pay to the labor, if I want G to be completed in 1 day in advance, the overtime I have to pay him is 25 rupees. So this will now become 7125.
Wasn't that cost for all the 4 days?
No, that's cost slope per day because you have divided it by the number of days. Now, right? Indirect cost. Now, indirect cost is, guys, now this is my critical part. 25 days is my project completion time and indirect cost is 200 rupees per day. So in that case, this will be 5,000. So in that case, when you add this will come to 12,125.
So you have to use the cost slope and all of that.
Yes, right? So now I have reduced the project completion time by 1 day and my total cost has also reduced, right? Now if you look at the cost slope table, guys, can we see the cost slope table? Look at the cost slope table. When you see the cost slope table, you can see that G can be crashed by 4 days. So I have only crashed it by 1 day. I will crash it by 4 days, but by doing it 1 day at a time, right? So now my second crashing will again be G, because I can crash G by 4 days. Second crashing will be G again by 1 day, right? So all those paths that have G will be reduced by 1 day. So this will still remain 21, this will become 24, 23, 20. Fine, do we get this in clear? So now my direct cost was already 7125. Crashing cost of G is 25 rupees. So this will become 7150. My project completion time is 24 days, right? So 24 into 200, that will give me 4800, right? Someone give me the total cost, 11950.
How did you get 24? You reduced it by 1?
Just give me a second. 11, how much? 950. Yeah, you were asking me something. How did I get 24? This is my critical path. No? So whatever is the time duration of critical path, I will multiply it by my indirect cost. Right? Do we get this thing clear? Then I have third crashing. Third crashing, again G by 1 day.
So take that critical path.
Yeah. Yeah. For indirect cost, I'll take the time duration of the critical path. G by 1 day. I'm going to reduce G again by 1 day. If I reduce G by 1 day, whatever path has G in it is going to be reduced by 1 day. This will remain 21, this will become 23, 22 and 19 days. My direct cost was 7150. Cost of reducing G by a day is 25 rupees, 7175. My critical path is 23. My critical time, project completion time is 23 into 200, 4600. So my total 11775. Right, do we get this thing clear? Next, I have crashed G by 3 days. I can crash G by 4 days. The maximum crashable limit of G is 4 days. So now I'm going to do my fourth crashing. G by 1 day. So this is 21, this is 22, this is 21, this is 18. Right? So now this is going to be 7175 is already my direct cost. Plus 25. 7200. My project completion time is 22 days into 200. 4400. So
11,600.
11,600. Right? Okay. So G has been crashed. The next thing that I have to crash, see, A, D, F, G. Out of which G is done. A, D and F. A has rank 3, D has rank 2. So the next I'm going to crash is D.
You have to keep on crashing
Yes, you have to go on crashing till the time you don't finish crashing all those
paths. And
activities that were there in the critical path. Fifth crashing. I'm going to do D. Now D can be crashed by 2 days. So first I'll do D by 1 day.
And those calculations in the end, the direct cost and all offer only the critical path.
Yeah. Right? You're going to be crashing only the critical path. Okay. D. Wherever there is D, I'll have to reduce that by 1 day. So this will become 21. This will become 21.
20.
This will become 21. And this will become 18. Right? The crash cost of D is 200 rupees. So this is going to be 7,200 plus 200. 7,400. This is going to be 21 into 200. That is 4,200. 11,600.
So you take that direct cost from there, or the 7,200?
Yeah, 7,000 from the previous one, the preceding direct cost plus whatever is my cost flow, right? D can be crashed by 2 days. Now we have a problem, people. Observe this step very carefully. 6th crashing. D can be crashed by 2 days, out of which 1 crashing I've done. So 6th crashing is D by 1 day. Now if I crash D by 1 day, observe carefully what will happen. This will become 21 because there is no D in it. This will become 20. Right? This will become 21 and this will become 18.
No longer than critical path.
Exactly. If I do this, now my A, D, F, G no longer remains critical path. What is critical path? It is the path that takes maximum duration. Now I have to make sure that this remains the critical path, for which I will have to make sure that this and this gets crashed. Now out of, in the first path A, E, H, I have A. A can be
It's the third rank.
A is the third rank. E is the second rank, and A is common to both of them. So I can do a crashing of A by 1 day.
So you do it over there only.
Right? So if I'm going to crash A by 1 day, this will become 20, right? And this will also become 20.
So what? The
but the
critical
normal
path will
will
become
be
19.
Which one?
Would
D will
Okay, yes, I have A in this also, right? So I have 20.
E. No,
E and C.
Okay, this was 21 days, this was 21 days. If I crashed A, then this will also become 19. So I'll have to take E and C and G. Between C and G,
C
what can
and
I?
C, G is done.
So G is done.
G
This
is
is
done.
done. E and C.
So E and C.
So E by 1 day and
C by 1 day.
C by 1 day. Right? So if I crash E by 1 day, then this will become 20. If I crash
C by 1 day.
C by 1 day, this will become 20 again.
And this will become 19.
No, it
I'm
doesn't.
crashing.
No, sorry.
I'm crashing D, E and C. Last path does not have anything, right? And A, D, F, G does not have E and C, right? Now, we will have huge problem here. 7,200 was my direct cost, right? To crash D, I had to pay 200 rupees.
7,400.
7,400 was my cost. To crash D, I had to pay 200 rupees. To crash E, I have to pay another 200 rupees. To crash C, I have to pay 600 rupees. 8,400.
Yeah.
My direct cost becomes 8,400. Right? This is 20 into 200. 4,000. So this becomes 12,400. Right? D can be crashed by 2 days. We've already finished crashing D by
2 days.
2 days. Right?
F.
Then F cannot be crashed. A can be crashed by 2 days.
So I mean E 2 days is
No, I'm only interested in those paths which are those activities which form a critical path. E and C I have to crash to keep my critical path safe. So I finish. See, my critical path is made up of A, D, F, G. Out of which I finished crashing G. F cannot be crashed. I finished crashing D. So the only other thing that I can crash now is A.
A.
Right? So 7th crashing. A by 1 day. If I crash A by 1 day, in that case I will have 8 crashes. So this becomes 19. 8 crashes, 19, 8 crashes, 19, and this is 18. Right? So in that case, this is 8,400 already my cost. Cost of crashing A is 250. So 8650, 19 into 200, 3,800,
12,450.
12,450. Fine. Next, let's crash this. A can be crashed by 2 days. So now let's see another crashing, guys. The last crashing. We did the 7th crashing. Let's see the 8th crashing. Again A by 1 day. If I crash A by 1 day, A can be crashed by 2 days, out of which one I have done. The next crashing I have to do 18, 18, 18, 18. So in that case, this was 8650 plus 250. How much is this?
88.
89.
Yeah.
And this is 18 into 2, 36.
1200.
12500. So I've finished crashing all the activities of the critical path. Okay, my crash table is ready. This is my crash table, right? Once you made your crash table, fine, then you've got to write your final answer. Now, my optimum project completion cost. Yes, very good. Project completion cost is 11,600. That's the minimum cost. My optimum project completion time.
21 days.
Project completion time.
20 days.
The 11,600. So that is 21 days, right? And once I have my optimum project completion time, I can also find out.
So, but this is for the critical path only, not 18 is also there.
The first is
no. I have to take only for
The-
critical
yeah.
part, right? Do you get this thing here? So I have optimum project completion time, and then I can have minimum project completion time. Minimum project completion time is 18 days. That's the minimum project completion time. So my optimum project completion time is 21 days at a cost of 11,600. Right? Do we get this thing clear? This finishes the sum. We'll stop this here for the day. Thank you very much.